Welcome to my video. Ẹ̀yin tèmi, ẹ jẹ́ kí ìṣàlùmọ̀ àlàyé kan fún yín nípa bá a ṣe máa ń tan fóònù láì lo bátìrì. Nínú explanation yìí, ọ̀nà méjì ni mo fẹ́ gbà ṣàlàyé fún yín. Ọ̀nà àkọ́kọ́ ni bẹ́ẹ̀ ṣe lè tan fóònù with DC supply láì damage phone, even tí ẹ bá mọ range ẹ̀. Another way tẹ́ fi lè gbà tan phone láì lo DC supply àti láì lo that same battery ti fóònù yẹn. Ṣé wọ́n pé ọ̀pọ̀lọpọ̀ ìgbà ni battery phone máa ń bàjẹ́, tẹ̀dẹ̀ máa need láti ṣe láì ra battery, tẹ̀ máa ní láti tan phone yẹn. The only way tẹ́ fi lè ṣe òun ni kẹ́ lo DC supply. Tẹ́ bá lo DC supply, ẹ lè tan phone yẹn. But the most common method tá máa ń gbà lo DC supply ni jumping method. A máa wá VBAT line. VBAT line simply means voltage battery. That is the positive leg. We will find the positive leg, then we will now look for the alligator clip of DC supply. We'll add it. Then we take the negative to the ground. Now, as it is like this, there is a full supply on this PCB at the moment. It depends on what I set my multimeter, my DC supply to give, that will be here. Assuming I set it to be around 5 volts, it's going to give this PCB 5 volts. Now, for you to be able to use DC supply, you must be an expert. In order for you not to damage phone, especially if you are looking for shorts or you want to short a particular section, it's very dangerous. That's why we gbọ́dọ̀ mọ nǹkan tí ò ń ṣe dáadáa kó tó lè lo DC supply. But now, to be on a safer side as a novice tó ṣẹ̀ṣẹ̀ ń kọ́ iṣẹ́ tàbí tó ti mọ̀ nípa ẹ̀ tí ò fẹ́ kí phone máa bàjẹ́ through the use of DC supply, because even gan phone voltage to man power phone is not stable, is always in range. Anything from 3.8, at times 3.5 can power phone, depending on the phone power consumption rate. 3.5 can power phone, 3.6, but the battery is usually 3.8. Now up to 4.2, I think the max is 4.2, but the rated voltage is around 3.85. Okay, limited charge voltage, this is 4.4. It cannot go more than 4.5, and the lowest I think is around maybe 3.2 or so. So now, why do I bring up this topic? It's just to give you a very important clue. If you want to use DC supply, make sure that you know the actual voltage of that board in order not to cause a damage. But if you don't know the required voltage for the PCB, assuming this is the device you want to power now, I want to on this device. The most common method of injecting voltage is the use of this line. This is the VBAT line, voltage battery line. We have the VBox around there, so you need to connect your positive alligator clip to this side, then ground the negative. Once you ground the negative, you supply the actual voltage needed by the device. In case you don't know the voltage required by this PCB, now that's where you have to get this kind of battery, either a condemned battery or the one that has lost voltage. As far as the battery, what do you need from this battery? Remove the battery flex. It's like this. This is the battery flex. Remove the battery flex. We call it BMS. Now, as far as the battery jet pay type of device ló ń lo clip yẹn, are you getting it? The battery jet type of device ló ń lo clip yẹn, you can use it to power it without the fear of causing damage. As how? Now, this device now, I don't know the required voltage at this moment, but I know that the general voltage to be used for this kind of device is around 4.2. So now we are going to inject 4.2 volts into this BMS. We will now read here the actual voltage that the BMS is going to give us, which means the BMS will be the one to control the voltage. If you put a 4.2 volt on this PCB, it will work. Ó máa ṣiṣẹ́ tẹ́ bá fi 4.2 so máa tàn, but ó lè ti pọ̀ jù. But tó bá kọjá through BMS yìí, tó bá kọjá through ẹ̀, which means eléyìí máa regulate it down sí nǹkan tí phone yẹn bá demand, nǹkan tí power IC bá demand látọwọ́ ẹ̀ ló máa give. Òun ṣe pé ó máa supply gbogbo iná tó bá wọ ibi báyìí, because ó ní OVC, then ó ní VCC, overcharging control, over discharge control. It has some resistor. This is a resistor as well. So function ni wípé kó wà lórí battery, kó máa regulate battery, the current flow, bí iná ṣe ń wọ orí battery bó ṣe ń jáde, nǹkan tó wà responsible fún lélẹ̀. Now you can have it in different type, like this one now is for Vivo. If I want to power any Vivo device, I will just put on my DC voltage. I put it around 4.2, that's the normal way. Then I ground this, I bring the other one, I connect to the positive probe. Now I clip it on my device. As it is now, the device will on. But what I injected here is 4.2. So let's give it a practical test now. Now I have another DC supply. Let's have it at 4.2. It's checking simply because I have connected it to the BMS. So now we have it at 4.2. Let's see the results we are going to get from this data sheet here. Let's use 5.0 for example. I have DC supply at 5.0. So we're going to connect it to this BMS now. So now we will now locate the VBAS line here to check the voltage that we are getting. We want to look for the actual voltage. How many voltage has this BMS step the current to? Ká bá lè mọ ìwúlò ẹ̀, 5.0 la gbé DCC. So now ẹ jẹ́ ká yẹ̀ wò, ká wo nǹkan tó máa fún wa. We find the VBAS line. What's this? This is 4.6 from 5.0, which means this BMS ó ti reduce náà yẹn sí 4.6. I think that's the maximum that the phone can use. 4.6, that's the maximum from the battery. Although if you trigger more voltage here, something like around 12, it will be forced to release more than that. It can release up to 10 volts, but that can damage the phone, and also some of the IC around here, it can get short. So if you inject higher voltage that you want to comprehend the flow of current to this point, it's going to cause a little damage. But now 5.0 that we injected has given us 4.6 here on the VBAS line, which means this flex is our Zephyr here. Òun ló gbà wá lẹ́ báyìí tí ó jẹ́ kí iná tó wọ orí ilé kó pọ̀ jù. So now anytime tẹ́ bá fẹ́ lo DC supply tí ẹ ò bá ti mọ voltage, or ẹ mọ voltage gan, tẹ́ bá ní something like this available, this kind of battery flex is recommended to use it, because once you use this, you are already on a safer side, and it will even give you more flexibility to work on the device. Unlike if you connect a terminal now, you cannot twist it around like this. If you made a jumper on the VBUS line, you can't have access to it. I can diagnose the device easily. Now there is flow, no battery, but it's connected, so I can check, I can look for shorts, I can even inject more higher voltage, and I will be able to work on it without any problem. So the benefit of using BMS is that it will continue to regulate the current flow to the device. So for no reason will there be damage to this board. There will be no damage. But if you know the actual voltage, which is around 3.8 to 4.2, you know, voltage is actually in ranges. It's range. It's not stable like that. That's why when you read voltage, you can never see it stable. It flows around. So once you have the BMS, you're on the safer side. But if you don't have a DC control, this is where we are going. If you don't have DC power supply, just find a battery like this kind of battery, but make sure that the battery is fully charged and is in good condition. Now find a wire, look for a wire like this, positive and negative wire like this. Connect the red to positive line while you add the negative to the negative battery line. Now assuming these two has been connected like this, you can now connect it with your alligator clip. If you don't want alligator clip, the alligator clip is the best so that it can serve a universal purpose. If it is connected to alligator pepper like this, assuming you are having your own connection like this, do you get, you have something like this. Now you can test any terminal. You can even use it to power small phone directly. If it ranges around 3.8 to 3.9, it will power this Itel Techno phone and if it power. But tó bá jẹ́ pé àwọn nǹkan báyìí lè fẹ́ fi power, it will be better if you just find the compatible BMS like this. Kẹ́ dẹ̀ inject sórí ẹ̀ sí the right point, kẹ́ fi tan phone yẹn, ó máa tàn easily. Tí ò ní sí pé bóyá iná tẹ́ fi sórí ẹ̀ ti pọ̀ jù àbí bóyá ó kanra wọn, ó máa give sound, ó máa dáná padà. No. There are many of it because you do change battery, I know. So there is no way you will not have Flex, Nokia Flex, Vivo Flex, Techno Flex, name it. These are BMS Flex. So there is no phone they are going to bring that I will not be able to test using the BMS sample. So it's better to be cautious than to make a mistake, because any mistake in phone repair, it's usually expensive. So this is it for this part. In the next part, we will be talking about what are the functions of all these major points. This is a VBUS line. This is a VBUS line. This is USB line. BAT power on, GND. What is it working for? These three lines. Now, this is RST, this is INT, this is RX and TX. What are they even working for? What is the frequency ratio? What are they communicating with? Are they communicating with the memory? Are they communicating with the NAND? Or are they communicating with the CPU? Or they are even communicating with power IC? They have their own function. How can you be able to make even use of them when a phone has a problem? How can you take advantage of all these points, including SCL and SDA as well? All these terminals at times can ease your stress of turning the phone around to the back side, because what you are looking for at the back side is already here. So you may not have a reason to turn it back. It's just like they make it an avenue for you to have access to this at the upper side instead of turning back. But you must know where they point to, which category do they belong. They are in 3 sections. This is the section, this is another section, and we have another section around the charging terminal. Around the charging terminal is around 4 as well. We have the positive, that's the VBUS line. We have the positive data, we have the negative data, and the neutral. On the battery charging port side, on the charging port side, This area is around SIM tray, some are working for CPU, and here is around battery connector. They have a function. With this and that alone, you can tell the problem of a device without turning it to the other side, and your diagnose will validate the problem 100%. So join us on our next episode. If you like this video, share, comment and like to have more of it. Thank you.